Good afternoon. My name is Sri Atmaja, together with my students Muhammad Fikri Priadi and Akyuta Anis Dewanto. We are from the Civil Engineering Department, Universitas Warmadewa, Yogyakarta. First of all, we also want to use this opportunity to thank you for giving us the opportunity to present our works in the Wuicace 2024 International Conference at Universitas Warmadewa. We're here to talk to you about the safety issues on railway transportation that we feel it is an important aspect in the transportation system. The focus of our works is the quantitative safety risk prioritization assessment of railroad level crossing. We take the case study on Yogyakarta level crossing. Briefly, we will present this material in four main sections. The first, introduction, that reviews the background of these studies, followed by the study approach in the second section, which is define the method we use to achieve our research objective. And thirdly, we present the study finding in this subsection, followed by the conclusion at the last stage. The conclusion will summarize the key insight gained and their implication for further research, and we hope that this structure will provide a clear and coherent understanding of our works and its significance in the broader context. In early 2024, there is accident occurred, three accidents involving collisions between car and the trains at the various railway level crossing on the same day. Gaya Baru Malam Selatan in Klaten region, Wijayakusuma in Banyuwangi region, and Datuk Blambangan in Tebing Tinggi region. This is tragical accident. Why? Because there are different crossing accident at the same time in 2024. Indonesian statistics indicate that more than 1,000 level crossing accidents occurred between 2019 to 2022. This number is quite high and is a critical issue for transportation safety. With the rising number of accidents, this concerning trend highlights the necessity of enhanced safety measures at the level crossing to prevent additional tragedies. Authorities and also related stakeholders should evaluate the existing level crossing and consider installing more safety infrastructure to reduce the risk for drivers and train operators. Moreover, fostering awareness and effectively implementing safety protocols requires collaboration between local governments, rail companies, and also communities. By prioritizing these improvements, we can work towards a future where rail travel remains safe and reliable for all. Railway safety is crucial as the railways promote sustainable transport and are integrally associated with the multiple Sustainable Development Goal (SDGs), including the establishment of resilient infrastructure that mentioned in the goal number 9. This aim of study is to assess the safety of railroad level crossing in Indonesia, with a particular focus on the case study in Yogyakarta. The finding will offer important details about the current challenges and associated with these crossings. Ultimately, there is six the proposed actionable recommendation to enhance safety and reduce accident in the region. The safety assessment employs a combination of qualitative and quantitative approaches, especially ARAS, additive ratio assessment, and HERADISI, hazard identification, risk assessment, and determining control, And the output of these methodologies is the prioritization of the safety risks at railway level crossing. The findings are anticipated to yield beneficial suggestions for improving safety measures and implementing effective control strategies at this crossing. The location of railroad level crossing were selected based on the complexity of their geometric configuration, and this complexity frequently increases the potential for accidents, thereby necessitating a thorough analysis and tailored intervention. Previous studies indicate that most reference regarding safety at the level crossing only concentrate on the examination of road user behaviors and the status of safety infrastructure, including the technology advancements. However, there exists a significant deficiency of research conducting qualitative risk assessment in conjunction with the quantitative analysis, which will clarify the vulnerabilities and susceptibilities linked to the hazards at the railway or railroad level crossing by integrating technical factors with the safety control measures. This study seeks to improve current model of railway level crossing safety, especially in Indonesia. And this is the research methodologies. We're starting with the field observation and the pilot study. And then the next level, we are conducting the data collection. And then based on this data, we analyze and give the interpretation. And after that, we starting with the modeling using the HIRIDC and ARAS. And last but not the least, the outcome of these stages, it is to formulate and develop the level crossing safety model, give the risk ranking, and which is expected to serve as a strategic recommendation for improving the safety of railroad level crossing. And this is a location of study. This location selected at that 10 Gordit level crossing. We usually call it a GPL based on the complexity of level crossing and also population density, the land use surrounding the level crossings. And then the results, this is the characteristic of level crossing infrastructure. We can say that based on this result, the existing safety device generally in constraint in the quantity, variety, and quality. For example, yes, sign 24A exists only in one location in GPL 348. So no sign 224 for the other GPL. And distribution of the 24B sign across the observed location is similar, inconsistent also. This finding indicates that the safety infrastructure at the railway level crossing remain inadequate and significantly ineffective. Another result from our research is traffic condition. Traffic is a critical issue in the level crossing safety. Increase of volume of traffic during the peak hours on the weekdays or weekend requires detailed observation. High traffic volume coinciding with the busy train schedule may significantly heighten safety vulnerability. And also, we can make any conclusion on this traffic condition by multiple by daily traffic volume by train passing. We also can make the categorization of the the level of GPL, the level of level crossing. If the number of passenger car unit multiple by train passing is more than 12,500, and the value of PCUT is mean that the GPL should be upgraded to grid separate crossing. Grid separate crossing is mean that it's not in the level crossing. it's a different level. And another result is about the queue and delay time observation. Similar with previous slide, the queue length and delay time at the level crossing shows the most crossing recorded at the highest delays during the morning peak, with the GPL 349 and GPL 736 exhibiting weekdays delays approaching or exceeding 70%. An exception was noted at the GPL 348 during the midday periods, where the holiday day delays, the holiday data, saw the delays exceeded those of the weekday, indicating this is the variation of traffic flow patterns. And based on the result of the feasibility survey, the feasibility is quite important, and it's calculated using the standard equation that's related to stopping side distance to vehicle and train speed. This table presents the minimum feasibility distance requires for the train traveling at 60 km per hour and the vehicle traveling at 40 km per hour. And mostly, we cannot get this feasibility analysis pattern in the level crossing. It means that the land use surrounding of the level crossing make the feasibility lower. And another important point is the lighting and noise measurement. The street lighting represents illumination intensity measured at the, of course, afternoon and the evening at its location. And that the noise, it is the result. So in approaching the minimum threshold, when we take the example from GPL 349 and GPL 350 and GPL 352, which is the noise level recorded approximately 89 to 90 decibel. It is similar or close to the minimum threshold. However, for other location, this significantly lower values. This finding indicates that no one of observed location meet the required minimum standard of 100 and 150 decibel for the noise. And another slide, it is the ARAS, Additive Ratio Assessment. This slide presents the output the ARAS analysis. The blue table displays the criteria alongside their respective weight derived empirically from the surface, and the purple table shows the decision metric that come from the ARAS calculation. And then the orange table shows the ranking resulting from the ARAS analysis, which compares its option based on the key values. The highest key values signifies a greater level of vulnerability or the risk regarding safety at the level crossing, when a lower values indicate the reduced risk. Another result is hazard identification risk analysis determining control. This is result from Hiradisi, and Hiradisi ranking is oriented based on the highest total risk assessment value is multiplied by probability versus probability and severity for each identified hazard type. And this also can rank significantly uh, uh, between the high risk to the other risk in the each level crossing. And for the conclusion, the combine of Iradisi and ARAS approaches successfully integrates and safety assessment in railroad level crossing. And this study indicates that the variable of traffic density, visible and improper number and condition of safety infrastructure contribute critical concern in the safety of railroad level crossing. And then this is the differences between Hiradisi and ARAS result. Almost both rank, both analysis is similar. The level crossing number 349, it is high risk, and then followed by 352. and 734, 732, and last is 727. It means that based on this analysis, we can rank the GPL, the level crossing from the highest risk for safety to the lower one. And thank you very much for your attention. Assalamualaikum warahmatullahi wabarakatuh.